Hi Calculus, we're going to do a short video here for continuing kind of an anti-chain rule. This time we're going to look at examples where when we do step 2 of anti-chain, when we divide, we don't get this perfect cancellation, okay? So go ahead and write down example 1. Remember that our steps are to anti-derive the outside, hold everything else, and then we're going to divide by the derivative of the inside, and at that step, everything has the derivative of the inside must cancel except for maybe a coefficient. So that except for part is what we're looking at today. Okay, so let's take a look here. Your outer function is x to the 5th power, right? So we're going to anti-derive that first. That'll be 1/6 x to the 6th. Now we're going to hold everything else. Okay, there's step 1 of anti-chain. Now we're going to divide by the derivative of the inside, and the inside is 1 minus x squared, whose derivative is negative 2x. Okay, so now when we cancel, notice that the x's go away, but I still have this negative 2, and that's okay. I'm not worried about extra coefficients. Now, if my variables don't cancel, we're going to have issues. We found the wrong antiderivative in that case. Okay, so we're just going to clean this up. 1/6 divided by negative 2 is the same thing as 1/6 times negative 1/2, so that's going to be negative 1/12 times the quantity 1 minus x squared all to the 6th, and let's not forget our plus c. All right, before we continue here, do we remember what the antiderivative is of something like this? Well, if you take off the 3 and the negative 7, you can see that our parent function is 1 over x. The outer function is 1 over x, whose antiderivative is ln of the absolute value of x. But remember, step 1, hold everything else, right? Then we'll divide by the derivative of 3x minus 7, which is the same as multiplying by 1/3. All right, now let's pause. You decide which one doesn't belong. In other words, each of these antiderivatives should have some form of ln, except for one of them. See if you can decide which one does not have a natural log as its antiderivative. All right, well, it turns out to be this one. This one has an antiderivative of the form arctan. Why do all the other ones work? Because you have a form of the derivative of the denominator in the numerator, right? The derivative of x cubed minus 7 is 3x to the power of 2. The derivative of x to the 5th plus 10 is 5x to the 4th. Again, remember those coefficients we're not too worried about. The derivative of e to the x plus 11 is e to the x. So let's try some of those. Before we do, remind me what the derivative of e to the negative x is. Should be negative e to the negative x. Chain rule, right? Outer is e to the x, but then we want to multiply by the derivative of the inside, which is negative 1. How about the antiderivative of e to the negative x? It's also going to be negative e to the negative x, because we want to divide by negative 1 this time, so we'll still have that negative 1 coefficient. All right, finally, I want you to look at example 2. Why don't you pause and write this one down? So what I want you to notice is that a form of the derivative of the denominator sits in the numerator, okay? So take a look at the denominator. And think of the denominator as your inner function. Think of this as 1 over u. Well, that antiderivative is ln of the inside function, right? But keep in mind, I need to keep everything else, okay? So I took the antiderivative of the outer. The outer is 1 over all of this, holding the inner, okay? Then step 2, I need to divide by the derivative of the inner. The inner is 7 plus e to the negative x. Well, that derivative is negative e to the negative x, right? So again, everything cancels except this negative. So a rewrite will be negative ln of the absolute value of 7 plus e to the negative x. And let's not forget our plus c. When in doubt, go ahead and take the derivative of what you found and see if you get back to this. I think you'll see that we do in this case. All right? So again, be real mindful when you're not sure what the inner function is, or what the outer function is, see if you can spot the derivative of the denominator in the numerator. If you can, then think of the outer as 1 over something. And that 1 over something should lead us to an antiderivative of ln. All right, let's take a look at this one. To me, it might be a little bit difficult to spot what's the inner, what's the outer. So let's start with a rewrite here. We can rewrite that x squared in the denominator as x to the negative 2. And similarly in the numerator, we can rewrite the 1 over x as x to the negative 1. Now if you'll notice, the derivative of x to the negative 1 is some form of x to the negative 2, right? So the outer function in this case is e to the x, okay? So let's antiderive the outer function, hold everything else. Then we're going to divide by the derivative of the inner. The inner function is x to the negative 1, whose derivative is negative 1 x to the negative 2. Notice once again, everything cancels except for this factor of negative 1. So final answer, negative e to the x to the negative 1 plus c, also known as negative e to the 1 over x plus c. All right, here's another one. Let's start with a rewrite. So I've got e to the x, and then I've got 7 plus e to the x to the negative 1/2. And we can see that x to the negative 1/2 would be the outer function, right? So if let's write that. That's my outer function. If I want to antiderive that, I'm going to bump the power up by 1, so I'll be at 1/2. And then remember to divide by 1/2, so that's 2. Okay, so this right here is the antiderivative of the outer. Now let's hold the inner, as well as everything else. I still have that e to the x, correct? Now we're going to divide by the derivative of the inside. The inside is 7 plus e to the x. The derivative of 7 plus e to the x is e to the x. So final answer, 2 times the quantity 7 plus e to the x to the 1/2 plus c. All right, I wanted to do one like this. If you have the dx in the numerator, keep in mind that's just like having a 1 in the numerator with the dx on the outside. So same thing, and I think this one also kind of deserves a rewrite first, right? So I've got square root of x in the denominator, so I can rewrite that as x to the negative 1/2. And then I've got this whole thing to the 5th power, but that's in the denominator as well. So why don't we rewrite that as 7, the quantity 7 plus square root of x. I'm going to write that square root of x like that, all to the negative 5th power. So you can see the blue is the outside. X to the negative 5th power is the outer function. Okay, so let's antiderive that first. Add 1 to the power, then that'll be negative 1/4 here. Hold everything else. So hold the inside, that's the red piece. Hold this factor of negative 1/2. Now if I do it right, that black piece has got to cancel, okay? So now, step 2, divide by the derivative of the inside, which is the red. Well, the derivative of 7 is 0. Derivative of x to the 1/2 is 1/2 x to the negative 1/2. And you can see here, good news, those go away, right? So I have negative 1/4 divided by 1/2. Well, dividing by 1/2 is the same as multiplying by 2. So 2 times negative 1/4 is negative 1/2. And then I've got the quantity 7 plus x to the 1/2, all to the negative 4th power. Those are some quick examples for you all. Go ahead and take a look at your problem set.